Hello, everybody. Welcome back to another day, another lesson. This lesson was very fun to do, and it's been a couple days. And it's because I actually made a mistake. Been doing this and almost short circuited the board, or I did, but doing the board is actually kind of smart and make sure it doesn't short circuits itself. So that's kind of cool. Anyways, I guess I kind of explained what I learned. It's pretty fun. You have to pay attention to the details. Anyways, let's get in. Let's just go ahead and go over what we're doing right now. So, anyways, this is the shift register or the 74HC595. Or I don't know. I just call it a shift register. And from what I like kind of interpret that from what I have interpreted it as, it kind of allows you to. It's like an extension of the amount of pins on the Arduino board. Um, yeah. Um, this was fun to do. I'm not exactly sure what it means feeding data using the data and clock pins of the chip. So I'm probably gonna look more into this. I understand this. Like the clock input is constant, the data input is not constant because that makes sense. So then I'm pretty sure you compare the two inputs to decide whether or not to like turn on or off the pin. Yeah, it gets pushed into the shift register. Zero, all the impulses. Latch pin, latch register. You know what? Okay, first I'm gonna talk on like how to like build the thing, make sure you don't like make the same mistakes I did, and then we're gonna go ahead and do some just searching stuff up because I did do some searching of stuff before this, but I don't have the greatest memory in the world. But anyways, let's go ahead and look at the wiring diagram. Okay, key things to remember is um, is you can actually be pretty free with where you put these LEDs, but the important things is you should keep a kind of a column. Yeah, you should keep a column gap between each LED. And the reason being is because, or at least from what I think, is that you want to make sure these resistors don't touch each other. Don't touch each other. When you're actually building building on the breadboard, you'll see how like even whenever you like have one column space between them, it's still kind of hard to separate them. So just make sure to make sure the resistors don't touch because I'm pretty sure that will short the circuit as well. Another thing to be very considerate of is says it down here. Is once you put in the shift register, make sure the little U-shaped notch is toward the top of the breadboard, i.e., this side of the breadboard. Um, and because pin one of the chip is to the left of the notch, so right here, this is pin one, and that makes sense because there you go, right here, left. And the reason being is because if you actually, what I did is that actually let me kind of show with my hands is that I actually flipped the register around. Oop, that's not good. I flipped the register around, and the issue was that then the inputs that were supposed to be coded, that was like let's say like the output was supposed to go to this first LED, like this first LED wire that I'm pressing right here. It wouldn't actually do that. It would actually like it would send a signal for whatever. I'm pretty sure this is the power. Yeah, it would send the input for the. It would just wouldn't work. Like it makes like the code would not like match up to the hardware, and it would just it was bad. So that's why you just have to be careful when you do everything. Um, I actually took it apart like twice. So I mean once is usually enough, but twice just gotta make sure. Then you can fully make sure that there's no mistakes. Now I just need to realize how to rotate this. So let's have a second. Oop. Oh, there we go. Now we'll just go ahead and set it there. Okay. But anyways, wiring is not crazy bad. Obviously, you have a wiring diagram, so it's pretty straightforward. Um, yeah, 5 volt. Yeah, pretty standard procedure. Yeah, not crazy bad. It was a fun build. I think I did mine on the board upside down. No, actually, no, I did mine right side up. Okay, yep, cool. A little haphazard because this was like very fun to play around with. But I also spent a lot more time. I'll spend more time like looking through the wiring and like because I need to figure out like what the power rows are as well, because I'm not completely sure how those work. I know the positive terminal. I'm pretty sure goes over here. Sorry, the negative terminal. The negative terminal goes over here of the LED, which makes sense because negative, negative, simple. I think. Am I right? We can easily check this, right? By just checking the LED, seeing which side is longer. Yep, the negative goes into the negative terminal of the power, which I feel like is explanatory. Okay, anyways, I'm also gonna go ahead and go through the code that's on here because honestly, I'm not even like I looked through it and even I'm a little bit confused. Like for example, like latch pin, clock pin, data pin. What's just okay? So we know what the clock pin and the data pin are. But what's the latch pin? Oh. For let's see what this is called again, or the specific lettering. So I'm just gonna copy this honestly. Mm, internal shift register the output. Okay. Okay, so basically, I'm pretty sure it's okay. So this is like, oh, okay. Wait, okay. This makes a lot of sense. Let's look at the hardware. Actually, we can just go back here. If you look at basically what I actually let's look at this one's so much more helpful. There are three inputs, right? 14, 12, 11. I'm pretty sure inputs, and which makes sense because they're connected to the pins. And I think these are inputs. Latch pin. Latch pin is 11. Okay, I'm gonna search this up later. A little bit confused. I should make sure. That's cool. I don't know what's doing that. Okay. Because the latch registers, clock pin receives, and each pulse the data pin is high, because 1% ratio this is 0. Okay, cool, whatever. Data pin, clock pin needs to receive. Okay, clock pin receives 8 impulses, so that's an input. The data pin is kind of like the variable, right? That goes like 1 0 1 0 1 0. Okay, whatever. And then the latch pin receives the 8 after, like this has done, and then outputs. So I think the latch is like the receiver, and then it outputs, and then it copies it to the latch register, which is I'm pretty sure the output of the shift register, which makes sense. Okay, I semi know how this works. The wiring is very interesting now, so I want to look into this. Wait, but this is like this at its face is not hard to understand. It's just assigning the pins on the Arduino board. This I found was interesting. Declaring a variable. They haven't done that in any of the code yet, which I thought was quite cool. Yeah, see void setup. It's yeah. This is what I was looking. They're all outputs. They're all declared as outputs. Wait a minute. Did I do something? Oh wait, so yeah, there are outputs on their Arduino board, but then they're inputs into the shift register. I think. I feel like that's a good way to think about it. I don't know if I'm saying nonsense or not, but that's what Tom did. I guess that's how you teach yourself, right? Okay. Dealing with upshift register. Okay, this is a cool method. Actually, okay. The loop makes sense. Uh, what data type? Remember that using 8 bits. Using 8 bits, each bit can be on and off. Which 8 LEDs? Okay, cool. Cool. Bits. So once again, I think these are specific Arduino IDE functions. I think. I just don't know. So I'm probably gonna try and search up the library and see if I can look through that. Yeah, this is by the way going to be the last lesson I think I'll do, and then I'm gonna start working on the actual thing. I'm gonna go to my school tomorrow and look at the garden that I can use and kind of measure it up, buy some PVC from Home Depot, and start making the actual hardware. I'm also going to Canada this Saturday, so I'll work on the software there, and hopefully when I get back, I can finish up the entire thing. So that's the plan. I just want to make sure I'm like familiar with the components I'm actually going to need. I'm kind of skipping over like the rest of the lessons because I only really need to know how to use the sensors, and I think I can figure that out. Okay. Anyway, shift register. See once again, digital write, shift out, shift out. Okay. I'm pretty sure this is calling on the shift right. This is calling the shift register. Visual write logic. I think this is turning the LEDs. Yeah, this is a bit clear. This might be turning it. This might be like these might be changing the LEDs. It's set LEDs. You know what? I'm gonna figure this out. I'm kind of just yapping now. I don't like doing that. Or, I mean, I like. It's not being very predictive. Okay, let's just go ahead and look, see how it looks, and maybe we'll come back in a second. Okay, very simple. I'm not going to show the code because like everything on the code is it's already in the PDF for a reason because it's a pretty interesting code. But anyways, we can see. Ooh, I just saw a problem. Okay, as you can see, it's light. They're all lighting up, and then and they turn off at the end. I'm pretty sure this is when all 8 bytes are like taken up, and then they all turn off. I think my resistor is just not fully in. I think that could be the issue. So let's go ahead and just try and fix that up. So let me turn it off first. I'm gonna grab another resistor actually because this is kind of a little bit dense. So many things. I hope they allow me to take the Arduino kit on the plane. Well, actually, I can just pack it into the suitcase, but yeah, better not to take a risk. Very cool. Yeah, that's weird. It was working before. Okay, pretty sure it's let in. Oh, see, like again, like you see how easy it is for these resistors. I don't know if you can see, like the resistors like are like very close to each other because I just been doing that. There we go. Resistor fixed. All the lights are going. Very nice. I'm trying to look at the loop again to see how this works. Update shift register. Bit set, update shift register. Bit set leads. Okay, yeah, that makes sense. Shift register, shift out. Okay, update shift register. Digital write, shift out. Okay, okay. I kind of go. I'm kind of understanding what the loop is talking about, but I'm still confused about what exactly the update shift register is doing. So I'm gonna go ahead and search this up in a second. But basically, what's going on here is that it's just looping through all the LEDs. I'm pretty sure that's what it's doing. Pretty sure. Pretty sure. Quite sure. I think. Okay. Yeah. I mean, it makes sense. Makes sense. It makes sense. Okay. Anyways, let me go search it up real quick. Yeah. Let's go ahead and do this. But yeah, as you can see, very cool. I actually might. I'm thinking of another mini project I can do. So many things I can do. Not enough materials, unfortunately. It's fine. I've already burned through so many resistors just trying to play around with some of the stuff. Maybe it's fine. Oh, I forgot. I only have one USB port available right now, so I have to go ahead and use. It's so cool how this just explains it to you. Anyways, okay, update shift register. Update the state of the shift register. The shift register connected to the Arduino, controlling multiple LEDs. Okay, duh. This is just what it's telling you. Set slash. Okay, makes sense. Yeah, it's void return type, which makes sense as well. Since the data is stored in the LEDs variable, okay. Okay. Yeah, this makes sense. Okay, let's go ahead and look back here. What is LEDs being changed anywhere here? Ah, there we go. Bit set LEDs I. Very cool. Very, very cool. So maybe yeah. I think I figured it out. Let's see. Ah, okay. There we go. So it's basically just it's turning on the LED. Ah, okay. So the code is turning on the LED, but we don't actually have a pin assigned to the specific LED, right? So let's say I'm trying to turn on the blue pin. I'm gonna turn on let's just for the sake of argument, we'll say like the LED since we're going from 0 to 8, the LED like the blue LED is 0, right? So we're setting. Ooh, wait, never mind. 0 1. It's set. It's update shift register. Actually, no, that still works. So I think we're changing LEDs to like I. So like in this case, we're setting it to 0, and we're updating the shift register, which is basically telling the shift register to turn on the blue, and then delaying 500 before we turn on the next blue, and the next yellow. Okay, I should just plug it back in, see which one goes first. Oh, there you go. Beautiful. See, it starts with the blue and then ends with the green, and that makes so much sense because after delay update shift register. Wait a minute. There's an update shift register first as well, which I find very cool. I'm assuming that turns everything off. Yes, that does turn everything off. Surely, right? Shift out. Yeah. Yes. That must turn everything off. Okay. I'm gonna leave it here. It's been a very long video. I've been kind of just yapping, but pretty sure I solved it. I'm gonna do more research into it, but I hope this was cool. I hope the colors are very cool because the colors are very nice. LEDs are super powerful. Remember your resistors. Remember your orientation. Oh, you got this. We got this. I'll see you in the next video.